Uh, Good evening, Selvan sir. Hello.
Sir, good evening.
Good evening, sir. How are you, sir?
Yeah, fine, sir. I'm doing good. How are
Okay,
you?
okay. I'm fine, sir. So we'll start the session, sir.
Okay.
So please introduce.
Good evening, all. Dr. M.P. Selvam is a professor in the Electrical and Electronics Engineering Department, National Institute of Technology, Tiruchirappalli, India, where he is associated with the Hybrid Electrical Systems Laboratory. He holds a PhD degree from Indian Institute of Technology, IIT Madras. He has 24 years of teaching and research experience in the field of power systems. His research interests include grid interaction of electric vehicles in smart grid, demand response, and P2P energy transactions in smart grid, distributed generation and microgrid, distribution system and custom power devices. He has published more than 160 technical research papers in various national and international conferences and journals. He investigated 6 research programs worth of rupees 160 lakhs. He supervised 7 PhD and 3 MP scholars and co-supervised for PhD scholars. He is also holding 6 Indian patents. He has co-authored 4 books. Thank you, sir.
Yes, sir. You can
Thank
share
you
your
for
screen,
the-
sir. Yeah.
Yeah, sure. Sir, hope the screen is visible.
Yes, sir. It is visible.
Okay. So, shall I start, sir?
You can put in expand this screen, sir.
Yes.
Slide mode. Yeah. Yeah, it's fine, sir. Now.
So, very good morning. Sorry, good evening, participants. Today's topic is hybrid electric and plug-in hybrid electric vehicle. Am I audible?
Yes, sir. Yes, sir. It's perfect.
Fine. Okay.
Your voice is clear.
So in this talk, we will see the growth of hybrid electric and plug-in
Sir, if
hybrid
possible,
electric
please
vehicle.
switch on your video. Because
Video?
this session has to be recorded. Yeah, your video is not on.
Okay. So I thought I may have some bandwidth problem. That's why I switched off the video.
It is there, we switch up, but now your voice is clear, sir. Very clear.
Okay. So shall I proceed?
Yeah. We can go ahead, sir. No issue.
Okay. So in this talk, we will see the growth of hybrid electric and plug-in hybrid electric vehicle and how these vehicles are interacting with the electric grid. What are the challenges and how can we address a few challenges, and case studies which we have carried out in our institute. Brief discussion on the results of the case studies. So first of all, we all know that we have IC engine based vehicles over long years, and these vehicles are keep on increasing on road because the population is increasing Every family is trying to have more than one four-wheeler. So number of IC engine based vehicles are increasing, due to which we are facing a lot of difficulty. One difficulty is demand for oil is keep increasing. So oil price is increasing. Oil may get depleted at any point of time. So this is one challenge. The second challenge is the emission coming out of these IC engines causing global warming. The temperature increases. In order to tackle these issues, people thought about electric vehicle so that we can avoid emission and we can avoid or we can reduce the demand on oil. So electric vehicles are battery powered. We can have hybrid mode, battery powered as well as IC engine based vehicles, or we can have pure battery electric vehicle. The idea to move towards electric vehicle is to tackle the energy crisis and global warming. This is the skeleton of a battery electric vehicle. You can see a lot of components from IC engines are replaced. Mainly the IC engine, gear mechanism are completely removed and we fixed electric motor and the motor drive. The fuel tank is completely replaced with battery banks. So other than these changes, we have the skeleton remained the same. We'll see the growth. The idea of having electric vehicles is not new. It started from 19th century, that is 1832. Slowly it was developing. In 1901, Edison designed the battery for electric vehicle. Then after that, between 1920 to 1935, the growth of electric vehicle is declining. Nobody concentrated on electric vehicle because IC engine based vehicles were doing very well. So concentration on electric car was declining. Later on, from 1968 to 1973, the oil prices, gas price was increasing drastically. So during this year, across the globe, everyone looked back into the use of electric vehicle or hybrid electric vehicle. So GM releases the EV1 in 1996. From that point onwards, several manufacturers started releasing their electric version of cars. The automobile IC engine based vehicle manufacturers started releasing the electric cars. 1997, Toyota introduces the first hybrid electric vehicle. So it was growing. From 1995, we could see a good growth in electric vehicle, both hybrid and battery electric vehicle, full electric vehicle. So during 2000 to 2010, after 2K, the research in battery technology also started developing. Because if you look at all these vehicles and look at the skeleton of the battery electric vehicle. The battery bank is the major part of the electric vehicle in terms of the components as well as the price of electric vehicle. The battery price decides the price of electric vehicle. If battery price goes down, the price of electric vehicle also come down. So research on battery technology started in 2000. And battery charging infrastructure, that is very important, right? Like fuel filling stations, we need battery charging infrastructure. Wherever we travel, we need to have charging infrastructure. If it is available, we can charge it whenever we need. So research in both these fields started rigorously. On the other side, motor drive, inverter technology, what kind of motor we can use, starting from induction motor, brushless DC motor, switched reluctance motor, PMSM, permanent magnet synchronous machine. So many manufacturers use different motors and different battery. It is in the growing phase. When the battery technology is growing, the capacity of the battery is also so important. How much energy you can carry on vehicle, that decides how long you can travel. So first plug-in hybrid vehicle with 60 kilowatt hour battery capacity was released in 2010 by GM. The model was Chevy Volt. Then Nissan released its version Leaf, 24 kilowatt hour battery. So now the concentration is how to increase the amount of energy that can be stored in the battery bank in the given space constraint. You can see in this picture how the batteries are arranged. So in types, as I discussed, we can have hybrid, plug-in hybrid, and pure battery electric vehicle. So all these vehicles, hybrid or plug-in or battery, all these types of vehicle need battery banks to be arranged in the vehicle. So energy capacity of the battery is very, very important. That decides how long we can travel. Right. So look at these three pictures: hybrid, non-plug-in, hybrid, plug-in. So non-plug-in vehicle cannot be charged from external charging port, external charging infrastructure, we cannot charge. In the non-plug-in hybrid electric vehicle, charging happens through the electric alternator present in the vehicle itself. Whenever it is driven by the IC engine, the alternator runs and it charges the battery through the electronics present in that. And from the battery, again through inverter, the motor is driven to run in electric mode. Plug-in hybrid electric vehicle has the same structure. Additionally, it has a charging port so that from external source we are able to charge. That's why it is called as plug-in vehicle. We can plug in the vehicle into an external socket. Battery electric vehicle does not have any IC engine. It runs purely on electric. It has battery bank, inverter, and the motor. So how IEEE defines plug-in hybrid electric vehicle? any electric vehicle if it contains a battery storage system of at least 4 kilowatt hour, which should be used to power the motion of the vehicle. It is not for ancillary services. This battery should support the motion of the vehicle. It should drive the vehicle. Then only we can call it as plug-in hybrid electric vehicle. Every vehicle has a battery for starting and to power the ancillary services. Maybe we have power drive, power steering, power brake. For everything, electricity comes from the battery. Those vehicles are not hybrid electric vehicles. Hybrid electric vehicle should have a battery which should drive the vehicle for motion. A means of recharging that battery system for an external source of electricity. Right? In the normal vehicle, automobile, IC engine based vehicle, what we use, we have a battery. It is not charged from an external source. It is charged during the travel. During the drive, the battery is charged. So if it is charged in that way, even the battery is used for motion, it is not plug-in hybrid electric vehicle. It should have a recharging facility from an external source. An ability to drive at least 10 miles. We can have more distance also. Without any gasoline, without use of petrol, without the use of gas, the vehicle should be able to move at least 10 miles. Then we can call it as plug-in hybrid electric vehicles. So this 10 miles, which we travel without using any gasoline, is called as all electric range, AER. So you can see in specification of a plug-in electric vehicle, this AER, all electric range. With only electric mode, how long I can travel. So normally PHEVs are represented like this: PHEV 30, PHEV 50, PHEV 70. This number represents all electric range in miles. So PHEV 30 miles, approximately 48 kilometers, we can travel in electric mode alone. I need not have any petrol. 50 kilometers. So assume it is an advantage. Suppose I have plug-in electric vehicle, suddenly the petrol tank is empty, which is not noticed. Then I can travel without any problem, refill the petrol tank. So this is the architecture of plug-in hybrid electric vehicle. We have a battery charger which can be plugged in to an external socket. Normally, it is called as wall box charging. If it is charged at home, or we can go to a public charging station where it can be plugged in for charging. So we have a battery charger. It charges the battery. It stores energy into the battery. Then from the battery, we have to drive the motor. If it is a DC motor, okay, we can directly drive. Even it is a DC motor, we need a power electronic system between the battery and the motor, because we need to control the motor speed. We need to control the motor speed, because there is no other mechanism to control the speed other than an electrical technique. So we need a power electronic interface between the battery and the motor. Even we use DC motor. Normally DC motors are not used. We go for an induction motor. We can go with brushless DC motor or permanent magnet synchronous motor. So all these motors are driven with the help of a DC to AC converter, which is an inverter. Right? And this motor is directly coupled with a wheel, so you can drive the vehicle without gear. It is directly controlled. The wheel is directly coupled with a motor. Since it is a hybrid vehicle, we have parallel path. From the fuel tank, we can have an IC engine. IC engine connects the wheel through gear or without gear. Both are possible. So here we need to have some kind of mechanism to either drive only in IC engine based mode or to drive in motoring mode, or we can have combined mode of operation. Both IC engine and motor can drive. So there should be a mechanism or a controller to choose these modes. IC engine mode, electric mode, or combined mode. We'll see that. There are three modes. Charge depleting mode. In this mode, IC engine is disabled. The complete propulsion energy is obtained from the battery until it reaches a threshold level of state of charge. Say, I have a battery with full charge 100%. I may fix a threshold of 40% SOC. I should not discharge below that. For emergency, I need. So during this period from 100% SOC to 40% SOC, PHEV disables the IC engine and it drives only in the electric mode. After reaching this minimum SOC, it shifts to charge sustaining mode. What is that? In that mode, IC engine propels the vehicle as well as maintains a charge above or near to the minimum SOC. So threshold we can fix. Then the third mode is charge blended mode. Both are employed here, electric motor and IC engine. They are applied automatically. That's why I said we need a control. Based on the drive cycle, it is used. So whenever we go with low speed, it will be in charge depleting mode. When you want high speed, we will move to IC engine based. So charge blending mode is both the modes are switched based on the speed of the driver, speed of the vehicle. What speed I want to use. Okay, now what are the converters we have in plug-in hybrid electric vehicle? Battery charger is a power electronic converter, AC to DC normally, or DC-DC. Then battery back, one bidirectional DC-DC converter. Bidirectional DC-DC converter because we can charge the battery from external source, that is from the utility grid, as well as from the alternator present in the vehicle when the vehicle is propelled by the IC engine. So we need a bidirectional DC-DC converter here. This can charge the battery back when IC engine is driving the vehicle. IC engine is coupled with a generator, so that generator provides the AC because it is an alternator, then it is converted into DC and the DC is given to this bidirectional converter. This charges the battery. So battery can be charged from the external source and the internal machine. Then this DC is given to the propulsion inverter which drives the propulsion motor. So, and at the starting point, since we use a battery charger, it may affect the power factor at the AC side. So normally we use a power factor correction circuit. Then from the battery pack, we may have a DC-DC converter. It may be a multi-port converter to give different voltages to the ancillary loads inside the vehicle. So many power electronic systems are present in the electric vehicle. Power electronic experts will be able to explain you how this individual power electronic converter functions and how should it be designed. So now we will have a brief idea about charging standards. So we have AC charging as well as DC charging. You might have heard about that. Level 1, level 2 AC or type 1, type 2 AC. And type 3 charging is DC fast charging. What is this fast charging? Fast charging is charging time. How quickly I can charge the given battery. If I am able to charge it quickly, then I say it is fast charging. These are all commercially available. Type 1 AC charging. We can pump 1.9 kilowatt, maximum 3.3 kilowatt, maximum 20 ampere current from 120 volt or 240 volt single phase AC supply. So this level 1 AC charging is designed for domestic charging purpose. We can plug in the electric vehicle in our home. But you look at the table given at the bottom, the charging time is 4 to 11 hours. 4 to 11 hours based on or 11 to 36 hours based on the vehicle. It is pure battery electric vehicle or plug-in hybrid electric vehicle, where the battery capacity differs. Pure battery electric vehicle has maximum of 15 kilowatt hour battery. Plug-in hybrid electric vehicle has 50 kilowatt hour battery. So you can see that according to the energy capacity of the battery, the charging time also varies in single phase home outlet charging. The second one, we can pump little more power, say 10 kilowatt. It is reflected in the current 80 ampere, either in single phase or three phase. Normally it is three phase. That cannot be done at domestic buildings. So we need to go for a public charging station or private outlet, because 80 ampere current cannot be drawn from domestic outlet. We are limited. We have limitation on the load that can be connected to our domestic circuit. We are not permitted to draw more current beyond, say, 20 ampere, maximum 20 ampere. So we need to depend on public charging stations and private charging stations. So when we go to a public or private charging station, the charging time matters. So even type 2 charging, you can see it takes 1 to 4 hours for pure battery vehicle, 2 to 6 hours for plug-in hybrid electric vehicles. So even in the public charging station, we need to wait for charging the electric vehicle. But the third one, DC charging, which is able to give more power, we need to depend on dedicated place because it is not available everywhere. Three-phase AC is available everywhere. So public charging station for three-phase AC can be built easily. First, DC fast charging, you need additional infrastructure. You need to have AC to DC converter, and then we need to provide charging to the electric vehicle. So charging infrastructure, building the charging infrastructure is expensive. So when you want to go to such charging stations, we may need to pay more for charging our electric vehicle. What is the advantage? By paying additional amount, we will be able to get charging in a short time period. Maximum of 1 hour, 20 minutes to 30 minutes, we will be able to charge. The picture on the screen gives you different charging sockets as well as the plugs. Type 1, type 2. These are all international standards. Manakis, Chadamo, or the international standards. We have Indian standards also. We'll see. Now, the battery requirements. As I said, the energy stored in the battery decides how long you can travel. There is a calculation. Battery capacity should be around 12 kilowatt hour for a passenger car to cover a distance of 65 kilometer at a speed of 50 kilometer per hour. So you can drive only 50 kilometers per hour. Think about the speed. Even within city, IC engine based vehicle, we try to drive at 80 kilometers per hour. Minimum speed on a normal drive will be 60 kilometers per hour in an IC engine based vehicle, which cannot be achieved in an electric vehicle. If you rise the speed, your energy requirement will be more, or the distance that you can cover will reduce. So here there are some commercially available plug-in electric vehicle. How much kilowatt hour battery is used? If you want 30 all electric range, 30 miles, small compact sedan vehicle needs 7.8 kilowatt hour. If all electric range increases, you can see that the energy requirement increases. Similarly, if the size of the vehicle increases, number of passengers that can be traveled increases, for the same all electric range, the kilowatt hour requirement of the battery increases. It is obvious, right? It is a known fact, but I'm just projecting what are the commercially available battery required for these vehicles, 30, 40, 60 AER vehicles. So now when it comes to battery, we want to have more battery. So battery size increases. That also will increase the weight of the vehicle, because battery is also carried along with the passenger. So along with the passenger weight, battery weight also should be calculated. So research is on how to reduce the battery or how to increase the energy density and power density of the battery. Energy density is watt-hour per kilogram. Power density, watt per kilogram. So we have to maximize both. Energy density also should be maximized. Power density also should be maximized. Energy density decides the range what we can cover as well as the size of the battery. Power density decides how much acceleration I can get I mean, how I can accelerate, how much I can rise the speed as well as the size of the battery. If you want to have more range, you should not accelerate more if you have less power density. If you want more power density, then battery size again increases. So these two are the deciding factor in battery technology. So in order to tackle this, now hybrid energy storage is used. Plug-in hybrid electric vehicles are coming with only battery energy storage or hybrid energy storage. What is the hybrid energy storage? Battery and supercapacitor. Supercapacitor is a component which combines the characteristics of the capacitor and battery. What is the unique characteristics of the capacitor? Capacitor cannot store more energy, but it can charge quickly as well as it can release energy quickly. Battery can store more energy, but it cannot release large amount of power as quick as that capacitor can release. So when we combine, we will get this power density and energy density. Whenever we want to accelerate, supercapacitor supports. Whenever you want to go in a normal speed and cover more distance, the battery will be used. So normally now the plug-in hybrid electric vehicles are coming with hybrid energy storage system. Of course, as facilities are increasing, the price of the vehicle also will keep on increasing. So battery charger, it should be efficient. Charger also should have power density, low cost, should have low volume and weight. The battery chargers are maybe unidirectional or bidirectional. If it is unidirectional compared to bidirectional, it has limited hardware, simple connection. It reduces the battery degradation because we will not discharge for any other purpose. But the bidirectional charges, you will be able to use the battery energy. We can give back it to the grid. But there is an advantage. Vehicle to grid technology. From vehicle, we can feed power to the grid. So people are thinking about using vehicle to grid for grid supporting purpose as an ancillary service to the grid, for voltage support, for frequency support. When group of vehicles or fleet of electric vehicles are able to support energy, then it is possible for frequency regulation and voltage regulation. Such electric vehicles should have bidirectional chargers so that the power can be fed out of the vehicle to the grid. But it needs a lot of power electronic converters and the associated controllers. Again, if you want V2G facility in a vehicle, the price of the vehicle also will increase. So these chargers are classified into onboard charges and off-board charges. So normally plug-in electric vehicle has onboard charger. We have two types of charging, conductive and inductive charging. Conductive charging, directly the charger is plugged into the socket through connecting wires. Inductive charging is a wireless charging. So research is going in that direction also. Off-board chargers, mainly for level 3 DC fast charging. It will not use the onboard charger present in the vehicle. it bypasses the onboard charger because it is an AC to DC converter. Now I am in level 3, I am directly giving DC. So I can bypass the onboard charger and external charging infrastructure feeds power directly to the battery. This external charging infrastructure is called as EVSE, Electric Vehicle Supply Equipment, EVSE. So we can see the power level. In addition to the time of charging, this slide shows you what are the charging power available. We have single phase, as I said, and three phase. We use 120 volt in the United States, and European Union and India we have 230 volt AC for single phase. Three phase we have 400 volt AC. See, this is what I said. Dedicated EVSE is required because we are using three phase power. We need to go to a public charging or private charging place. We cannot use the home outlet. Only the single phase we can do at the home. What is the battery capacity? How do we decide on that? Battery capacity, the energy capacity of the battery is the product of ECPM and AER. What is ECPM? Electric energy consumption per mile. Right? Kilowatt hour per mile. How much energy will be consumed to travel multiplied by the all electric range will give you the capacity of the required capacity of the battery in kilowatt hour. So this is ECPM is going to vary depending on the vehicle because it is something like a mileage. How much kilometer I can travel or how much mile I can travel with 1 liter petrol. It varies vehicle to vehicle. Similarly, here also we have a small vehicle, large vehicle, which can carry more number of passengers. The mileage differs. So for a given vehicle with a given mileage, how much distance I want to cover with only electric mode, based on that, we need to get the capacity of the battery. Then SOC of the battery, once the travel started and returned back to the charging place, say the home, which can be calculated like this: 1 minus lambda d by AER into 100. That is the available SOC. What is lambda d? Lambda d is the distance driven in the electric mode. How much distance I have traveled. And what is the AER of that vehicle? So PHEV 30 means 30 miles is the AER. Say I used 20 miles in pure electric mode. So 1 minus 20 by 30 into 100 will give me the available SOC. It's a given idea, right? But normally the vehicles in dashboard, we will be able to see everything. All these calculations are done. It is displayed to the driver. That is required, right? Because in IC engine, when we start, we will be able to see how much petrol is available. Whether the petrol is low, there will be an indication given. So similarly, in the PHEV also, all these indications are available. But as a teacher, as an engineering teacher, we should know how they are calculated and displayed. An amount of energy required to charge PHEV battery after the last trip. This is very much important, right? how much energy you need. It depends on the present SOC and the SOC level what we want. Normally we want 100% SOC back from the present SOC. So how much energy is required? Because it is going to decide when the vehicle is plugged in, how much energy is going to draw. We are going to draw from the grid. For that, we need to pay. In the normal situation, it doesn't matter. Because if the electricity tariff is flat, okay, I don't worry. I just plug in, charge it. Based on the number of units, I am going to pay. If electricity tariff is a variable, particularly time of use tariff, then this is very much important. How much energy I am going to draw. If I charge during the peak hours based on my requirement on the vehicle, whether do I need to charge to its full capacity or only to certain level, later I will charge when the price is low. So I need to decide. So I need to calculate how much energy is required to charge it. So what is CC is the usable capacity, the total capacity of the battery. So total capacity of the battery in kilowatt hour. I think we all can calculate kilowatt hour of the battery because ampere hour is known, the voltage of the battery is known. And we should understand how the batteries are connected in the vehicle, whether it is in series or parallel, what voltage level it is working. So based on that, we will be able to calculate how much is the energy capacity of the battery. Normally, it is given by the manufacturer. Based on our interest, we want to design a system, so we want to understand this, so we can calculate that. So this is the total energy capacity of the battery. And this SOC says the present SOC. One is the SOC what I need, 100% SOC. So using this, we will be able to calculate how much energy required. So of course, the efficiency of the battery charging process is also important. So EC is the how much chemical energy required in the battery. And the actual energy, what is drawn from the grid, we have to calculate with the help of efficiency of the battery charging process. So the efficiency also we need to read from the data sheet of the manufacturer, what is the efficiency. Then we will be able to calculate what is the energy required. So this is about the vehicle and the battery charging. How can we calculate the energy requirement? How we are going to charge? We are going to charge from the socket available in the domestic building or public charging stations or private charging stations with DC charging. Whatever it may be, all these buildings are connected to the grid. So we are going to draw electricity from the grid for charging electric vehicle. Doing this, there are some positive impacts and some negative impacts. So before talking about this, if any participants wants to interact, we can have 2 minutes interaction.
Participants, you have any questions? You want to clarify anything? Any clarification?
Okay. If no questions, then we will have the questions at the end.
Yes, sir. Yes, sir.
Yes. So whenever we interconnect the vehicle with the grid, we have some positive impacts and a few negative impacts. Positive impacts comes only if we have energy feeding facility in the vehicle. That means if you have a bidirectional charging facility, bidirectional charger in the vehicle, then we can have grid to vehicle and vehicle to grid mode. Then only we need to talk about positive impacts. We can do power management, it can be used for power quality improvement. As I said, it can be used for voltage and frequency regulation. And whenever renewable energy, people are thinking about using the energy stored in the electric vehicle for smoothing the renewable energy variations. So these are all possible only with bidirectional battery charger if it is available in the vehicle. So whenever we look into the electric vehicle, we should see whether it is vehicle to grid enabled, vehicle to grid technology enabled vehicles. In the market, very limited manufacturers provide vehicle to grid. According to my knowledge, Tesla provides such facility in one of its model, vehicle to grid. Very limited manufacturers are providing that because this part is under research and a single vehicle cannot support the grid. There should be a pool of vehicles to be ready to support the grid. And there should be all other mechanisms. How can we handle the vehicle owners and the grid operators when we need grid support from the electric vehicle? So since it is in the preliminary level, not many manufacturers are concentrating on V2G enabled vehicles. But it is possible. If you look into the research articles, you will get lot of research articles providing voltage and frequency regulation with the help of electric vehicles. But even with a normal PHEV or BEV, without vehicle to grid technology, we will have negative impacts on power. Because the load demand is going to increase, the first thing. Number of electric vehicles are increasing on road. See, we started from the first slide. I said number of IC engine based vehicles are increasing because of the demand on oil increased. Now, number of electric vehicles are going to increase. That will lead to demand on electricity, right? So, low demand increases. Suppose the increase in demand happens or it overlaps with the peak demand period, then there will be a component overloading. Our peak time, say in the evening hours, in the same time, if charging of electric vehicles happens, the distribution transformers may get overloaded, distribution feeders may get overloaded, substations may get overloaded. So component overloading is another issue to be tackled when number of electric vehicles are increasing. Then when we have single phase charging, there may be a phase and voltage imbalance that may happen because single phase charging, there may not be a balanced charging in all the three phases of the distribution transformer, which may lead to unbalanced current because the current drawn for charging is more. That may lead to more unbalance than which is normally present in the distribution system. Distribution systems are designed to tackle certain level of unbalance because we have more single phase loads. So our neutral conductors are designed to cater certain level of unbalance. But if unbalance level increases beyond the expected value, the neutral conductors cannot withstand the unbalanced current that flows through the neutral. Then this charging is done through power electronics converters. So there may be a possibility for harmonic injection, stability issues, increase in power loss. So there are so many negative impacts are expected by power system operators in near future when number of electric vehicles are going to be more on road. Now we have very limited electric vehicles, but it is increasing day by day. It is increasing. So in near future, we may have more vehicles. During that time, power system operators will face these issues. So now, for power system engineers or the researchers who are working in power system point of view, these are the research problems that can be addressed. There is another aspect which I want to share with you quickly before going to enter into the case study. Economic aspect. Why the electric vehicles are going to increase? There is an analysis. One point is the demand on oil should be reduced, and we want to tackle with global warming, that emission we want to reduce. But when you concentrate on electric vehicle, if the price is more, then it is very difficult to get changeover from IC engine based vehicle to electric vehicle. So economic aspects are very, very important. But as I said, if you look into the procurement cost, there is an article in literature which says 40% of the price of the medium size car is decided by the battery pack, price of the battery pack. So in turn, we can think if the price of battery drops, definitely the electric vehicle price also will drop. But there is a evidence for falling price of battery. That article gives this information. 2010 per kilowatt hour lithium ion battery costs $1,000 per kilowatt hour. Now it is decreasing. Here you can notice 2018, it's a little old data, right? 6 years ago, before 6 years, the price was 176 per kilowatt hour, $176. See, there is a drastic reduction. Now, definitely it might have reached $100 per kilowatt hour or less than that. We have to look into the present data. Definitely it will be much less than this. So there is a pattern of decrease in price of lithium ion battery. So definitely procurement cost of the vehicle also will come down. It is anticipated. And when we look into the operational cost, as a purchaser, I will look into the operational cost. Maintaining electric vehicle, whether it is good or bad compared to IC engine. How efficient the electric motors are. Of course, all electrical engineers, we should appreciate our electrical machines, which are having almost 90% efficiency. When we look into IC engine, we may not get more than 30 or 40% efficiency. Similarly, fuel price per unit cost of electricity, per unit cost of gasoline. Gasoline price are more. So operational cost is going to be less, very much less for electric vehicles. When I say operational O&M, maintenance cost, of course, electric vehicles have very limited moving parts. You look at the IC engine based vehicle, from IC engine, the power has to be transmitted to the wheel. They call transmission mechanism, power transmission mechanism. It has a lot of moving parts. But in our case, it is directly coupled with the wheel. So very limited moving parts. And there is no oil used in electric vehicle. Not in plug-in electric vehicle, in BEV, battery electric vehicle. So definitely maintenance cost also comes down. Of course, the battery replacement cost has to be considered. Right now, the manufacturers guarantee 8 years usage. 8 years usage. And government is providing a lot of incentives in terms of reduction in GST and in FAME 2 program. Some of you may be aware of this FAME, fast adoption and manufacturing of electric vehicles. A lot of incentives are given during the purchase. So with that, definitely the price of electric vehicle on-road price will be much less in near future. Here there is a comparison which says you how much we need to spend to travel 1 kilometer. Considering the electricity price as 6 to 8 per unit, normally in all the states, this tariff may be a commercial tariff. Domestic tariff will be much less than this. So commercial electricity tariff is taken and the oil price is taken as 70 per liter. Now the petrol is 100 per liter and diesel is around 90 per liter. So both the price, electricity price is much less than this if you go with domestic charging. The present oil price is more than this, right? So with that, if we compare, the price per kilometer travel will be less than 1 rupee. Here, the price per kilometer travel will be around 5 rupees. So obviously, this comparison will make me to choose electric vehicle. But only the drawback, how long I can travel. That is called as distance anxiety. That is the limitation in electric vehicle. How long I can travel in single charge. That is all electric range. IC engine, we have long range. So range anxiety is the only problem which will give second thought for the vehicle purchaser. But for the city ride, every day you want to visit and come back to home and charge, electric vehicle is the best one. Yeah, I said I will talk about some Indian standards. So here you can see some of the Indian standards, which are called as Bharat standard. Bharat EV charging AC001. It uses 15 ampere 230 volt 3.3 kilowatt, which is available in our residential building. For high power, we need to go with type 2 charging, where we need to have a dedicated EVSE. And DC charging, we have Bharat standard DC001. Of course, it should be done only at the charging, with the charging infrastructure. But Indian manufacturers like Mahindra and Tata Motors supports DC fast charging. The charging standards are equivalent to international standards like CHAdeMO and CCS, combined charging mode. Just for an information, I'm sharing this. So when we have all these electric vehicles, we will dream that before we go with an electric vehicle, our home, we will have inbuilt power generation also. Because both of them are growing simultaneously. Electric vehicles technology or plug-in electric vehicle and renewable energy, incorporation of renewable energy, incorporation of smart meters, everything is going in parallel. So in near future, we will get smart homes where we will have advanced metering infrastructure, in-house power generation through renewable energy, and plug-in hybrid electric vehicles. So now the charging, we will talk about the problems, residential EV charging. Most of us will go for residential EV charging. Because when you go with the public charging, the first thing, the price, electricity price for charging price will be higher. In residential, we can go with domestic tariff. So time doesn't matter, you just come and plug in, let it charge for 8 hours or 10 hours. Next day, okay, I'll take it. So we'll talk about the domestic charging. Not only in our country, in most of the countries across the globe, we can see the consumers think about charging in the residential building. Like this. This is the photograph with wall box charging. Okay. We can normally plug in the normal plug. Definitely we can charge it. But standards doesn't recommend. Standards do not recommend this. Even for Bharat AC 001 domestic voltage charging, the standard recommends use of EVSC, electric vehicle supply equipment, which provides additional care, which provides additional protection. So whether you use AC 001 or type 2, we need to go with EVSC. That is the recommendation given. So it is called as wall box charging. It costs around 40,000 rupees in India for AC 001. If you want higher power level, where you need to use 3-phase connection, so the charge EVSC is around 65,000. If you go with level 1 DC charging, where we can pump 15 kilowatt, the EVSC is 2,50,000. But it is supported by Tata and Mahindra. So if we are affordable, we can buy this EVSC and we can do domestic charging itself. But we need a 3-phase connection. Otherwise, we cannot do, because it handles large quantity of power. So without 3-phase connection, we cannot do. But nowadays, residential buildings are provided with 3-phase connection. Many residential buildings, people would like to have 3-phase connection. They pay additional amount and get 3-phase connection. So if you are affordable, we can go with this kind of charging also. Level 2 DC charges are more expensive. It goes 10 lakhs. So normally we have to depend on public charging stations because it is almost equivalent to the price of an electric car. So nobody will spend for this. We can go to a charging station and do it. But my point is, whatever may be the charging station, whether you do at residential building or public charging station or private charging station, we are going to draw power from the grid. Either 3 kilowatt or 7 kilowatts or 15 kilowatt or more than that, 25 kilowatt or 150 kilowatt, we are going to draw. So the load is increasing in the system. That is what the problem we are going to discuss. Burden on power system. Supply, demand will keep on increasing. So it will have an impact on peak demand. So there is statistics based on the study. Since we do not have many electric vehicles in India, we do not have such statistics, how much peak demand is going to increase. But in research articles, we can find out in abroad countries. 25% share of EV shows 19% increase in peak demand. When the electric vehicles are connected to the grid in an uncontrolled fashion. What is uncontrolled fashion? Whenever I want to plug in and get charged. If it is done, just 25% share of EV will increase almost 25%, say 19% is final theoretical value. So practically it may be 25% increase in peak demand. So 100% EV, 100% increase in peak demand. Very difficult to manage. So similar study in the United States demonstrated 4% of the distribution transformers are overloaded. When 5% penetration is there. And similarly in UK also there was a study, My Electric Avenue project, like our FAME, fast adoption of electric vehicle, for adoption and manufacturing of electric vehicle, they have My Electric Avenue project. They showed 32% of the distribution circuits need upgradation when they have 40 to 70% share of electric vehicles. So in different countries, we could see increase in peak demand. So definitely, we can also expect in near future increase in peak demand, overloading of the distribution transformers. So capacity enhancement is required in the power infrastructure. Capacity enhancement is again expensive. Normally, this problem should be handled without enhancing the capacity. That is a wise idea. That's a smart idea. So we'll see a case study on this. Overloading of distribution transformer. The problem is very well defined. Whenever you increase the number of electric vehicles, distribution transformer is going to get overloaded. So that I will show. And the solution is coordinated charging. We should not allow uncontrolled charging. There should be a coordinated charging, which will help this. So I'll show the case study and results. So we have taken a 4-bus system. Along with the household, we have EV loads. So you can see here, there is a overloading of the transformer. Transformer capacity is 63 kVA. So in a short period of time, from say 5:30 p.m. to 8 p.m., there is an overloading of the transformer that happens. So the sustained overloading will reduce the life of the transformer, or during this period, we may expect interruption of power due to the blow of fuse. Since it is a simulation, we could see overloading. Practically, if I overload the transformer, if the fuse, there may be a possibility for interruption of power, or If fuse is able to withstand this overload, sustained overloading of the transformer may lead to reduction in the lifetime of the transformer. So this should not be allowed. So somehow I need to manage this and go to coordinated charging. So this is one problem in the distribution transformer. Further, this overloading will lead to additional voltage drop and power loss in the distribution network. So that should be also tackled. So both of these two issues, voltage drop, power loss, and overloading, can be easily tackled with coordinated charging. I'll directly go into that because of the short of time. For more information, you can go through the research article. Okay, I'll show that also. So we need to go with the priority based charging. That is what coordinated charging. Priority should be given for the consumer. It should be calculated and applied. So when we calculate priority, customer will not agree for that. So there should be the flexible pricing system so that we can attract customers to undergo this priority based charging. So when we do that priority based charging, overloading on the transformer can be well limited. And of course, there is no much difference. Without priority, the customers, all the customers charged their vehicle at 10:45 p.m. Here only 30 minutes extra that happened. But during these 3 hours where transformer got overloaded in the uncontrolled charging, in the controlled charging, transformer overloading is avoided. The charging is done in a priority based manner so that all the customers are charged to its full capacity with only 30 minutes delay. It is not a major problem, right? In this case study. Similarly, I will not go into this. You can go through the literature later. We can model it as an optimization problem to limit the power loss and the voltage drop reduction. With coordinated charging, we could get better voltage profile, reduction in power loss, and the reduction in peak load. That is what expected, right? Peak load will affect planning of the grid itself. We need to reduce the peak load. This is achievable with coordinated charging. So how do we do coordinated charging? It depends on either priority or we can make an optimization. Flexible pricing scheme can be introduced. So more information can be obtained from these sources. And these are all the recommendations given by NSGM report. I suggest all of you to go through the National Smart Grid Mission portal where we will get a lot of information about the adoption of smart grid and adoption of electric vehicles, everything. In Delhi, they have made some case study. So they said we need to enhance the grid capacity also. I mean, generation capacity also should be increased in order to tackle EV. So it is better to go with renewable. So renewable capacity should be increased. So charging stations should have rooftop solar generation so that dependence on grid can be reduced. Clean energy can be promoted. These are the recommendations. You can go through it. Finally, it comes to peak load management. So for that, dynamic pricing model can be employed. And smart grid tools. This is what the coordinated charging. So smart infrastructure is required when we talk about coordinated charging. So for that, first of all, smart grid should be implemented. Then we need to think about the coordinated charging. So fleet of EV is the future power grid. In order to tackle this additional load, grid infrastructure should become rich in capacity. Capacity should be enhanced. As I said, it is a financial issue, capacity enhancement. So on the other hand, we can make the grid operation smart to manage the huge demand. So coordinated charging is one kind of demand side management to tackle the huge demand with renewable energy sources, which will be possible because in all the states, the utility is trying to implement smart grid. So as use of electric vehicle increases, the implementation of smart grid also will be completed. So definitely we can aim coordinated charging, demand side management. Without the capacity enhancement, the smart operation of electricity grid will happen in near future. Thank you for your attention. If you have any queries, we can have.
Participants, sir, there is a question on chat box. Can you go, you're able to read the chat? Dr. Vikram Kulkarni has asked one question.
Yeah, can we relate the energy tariff in India and foreign? In India, we have slab tariff. If number of units consumption rises above 300, the bill gets doubled. And if it is more than, in Mumbai area where I'm staying, in winter also we have 350 units of consumption. Unlike in some countries, it is hourly tariff and dependence is on renewable rather than conventional. Example 10. Yes, it is good. It's a good question. That's what I said. When you want to limit on demand, we need to definitely go for a variable tariff. By providing variable tariff, we can change the behavior of the customer, behavior of the low demand, which will help both operation of the grid, managing the peak demand. Same time, since customer changes their behavior, means use of electric appliances, they will also get benefited. So variable tariff is very much required, not the slab rate tariff. And of course, as NSGM recommendation, electric vehicle increases, the demand should be met by power generation from renewables. That is a strong recommendation from NSGM. Even if we have electric vehicle at domestic, even we charge through the socket available at domestic, we need to have in-house power generation so that the energy requirement can be met.
Yes, sir. Yes, sir. Thank you for your answer, sir. Still, if we see, sir, I have one more question. Kindly allow me. So now, if we see even the load balancing through different WRLDC portal or this RDC portal, Western Load Dispatch Center portals, there is a great deviation between what is actually scheduled and what is actually being demanded. Now, if you see the curves that is happening every day, with 1 hour interval also, there is a great difference. Now, in this particular, I think this load balancing issue also is important when we are talking about this particular electric vehicles. Also, in the long term, like if there is a long journey, do you think that enough number of charging stations are being provided? Even I think that is also one issue. where I think
Yes,
the
yes, exactly.
capacity of electric vehicle will be limited within 100 kilometers or 200 kilometers as per now.
Yes. Now we have very limited infrastructure for charging stations. That also should be increased.
Sir, one more question on the chat box. After all these benefits, why don't people prefer EV today?
No, actually people are preferring EV now.
Slowly,
Maybe
it is
the
increasing.
range anxiety is the only problem. How long we can travel with one charge? If we are comfortable with city drive, people are preferring EV now.
Yes, yes.
Sir, good evening, sir.
Yes.
Sir, this is Krishna Rao. Hello.
Please proceed, sir.
Selvan,
Sir,
can you switch on your video? We have to take some screenshot.
Yeah, yes.
Switch on the video, then
Sir.
Mr. Dr. Chalakrishna, you can ask the question. Okay.
Sir, can you explain merits and demerits of regenerative braking in real-time scenario? Regenerative braking, sir. Merits and demerits of regenerative
Sir,
braking in real-time implementation. Sir, can I?
maybe it is a regenerative braking is a question which deviates from the present topic. So some other time we can discuss. Even you can email me so that I can give you a reply. What is the exact
Okay.
question what you would like to ask?
Okay, sir. Thank you. Thank you.
Hello, sir.
Thank
Good
you.
evening, sir. This is
Yes.
Satyajit Sahu. Sir, those who want to do research in this field, like young students or researchers, what advice from your experience you would give to start research in this domain? What you are explaining, sir? Any specific advice?
Sir, specific advice for their advice in the sense they need to do a detailed literature survey first. The problems are addressed. Many problems are addressed in the literature. Okay, but it depends on their own country scenario. So we can look into the scenario of our country and we can find a problem and we can address that. See, I said coordinated charging. Even we try to address the coordinated charging, but the tariff what we have does not support the coordinated charging. How to attract the customers to adapt themselves for coordinated charging? Because if we call and if we ask the consumer to wait for charging one by one, then they will not listen, right? Nobody will listen because there should be some benefit. So how to introduce some kind of incentives to them? In that direction, people can think so that coordinated charging can be promoted. Then second point, with respect to electric vehicle charging stations, there are a lot of scope. How to manage the electric vehicle charging stations? They should not completely depend on electricity grid for obtaining charging power. They should have their own power generation. So how to manage that power generation along with the grid and the charging? So there is a lot of scope available for the research scholars to work on charging stations, public charging stations, high power public charging stations. And the third one, there is an avenue when we talk about this vehicle to grid technology. As I said, even in Indian grid, there are proposals to go for frequency control with the help of battery energy storage systems. So in future, there may be a thought or there may be a proposal as number of electric vehicles are increasing to handle frequency regulation problem with the help of group of electric vehicles. So this is another direction scholars can concentrate.
Thank you very much, sir. May I ask one more question? Sir, you told about the
Yes.
break evens of the what is the per kilometer rate we are getting for a electric vehicle if we use against a diesel vehicle. So basically, it is around 2 to 3 rupees. But what about the life of the battery, as we are using it in a EV and we are just 4 to 5 years into it, and slowly the life of the
Yes,
battery
sir.
will come into question as well. So will that impact the, as you said, the range anxiety is one factor that is affecting people from choosing EV. Once the life of the battery is also like the companies guarantee that it is 5 years or 6 years, 6 years the battery will last. Say for example, if the battery lasts more
Yes.
also, so that can also give a positive impact on the people choosing EV. Or if the battery life is less, then the people will start switching back to diesel or petrol cars again, sir.
Definitely. Yeah, that is true. So now actually most of the manufacturers guarantee 8 years. Some of the manufacturers, they guarantee 8 years. But we need to wait and see how long the battery life is available for us. So definitely if the battery life is more, people will prefer EVs. But right now, we can try with PHEVs.
Thank you, sir. Thank you very much, sir.
Good evening, sir.
Okay,
Thank
sir.
you.
Okay, please go ahead.
Good evening, sir. This is Dr. Sashmita Padhi. Sir, actually, I wanted to know, like, somewhere like you mentioned, when we are going for charging the EV, like public charging, when we are going for, the cost is more when we are going with this domestic charging. So, like, how you can, I mean,
Yes,
we can
yes.
say, like, by how much it will be increased if you'll be going for this public charging, and for what reason you are saying, like, the domestic charging will be lesser if will, I mean, the cost will be less when we will be comparing with this public charging. Because when we are having a charging station, they must be having some like renewable energy also, and not at all, I mean, totally they are not depending upon grid, perhaps. So in that case also, like, I don't think that
Yeah,
be
of
the
course.
cost will be that much.
Yes,
Can you
madam.
please clarify that, sir?
When
Like
you
how
go to the
come it is and
public
by how
charging,
much percentage it will be increased, sir? If it will be or decreased, if it will be going with this domestic charging, sir.
see the public charging station, they have to build the infrastructure, right? Like a petrol pump, they need to set up the infrastructure.
Yes, sir.
So there is an investment involved. So definitely they cannot give electricity at the domestic tariff. They need to go with an industrial tariff minimum. With respect to our state, the domestic tariff starts from 3 rupees, but industrial tariff is 7.5 rupees,
Okay.
double the charge. So public charging stations may charge industrial tariff.
Okay. Okay. So is sir, like, is it always like advisable to go with this domestic charging if we will be having a EV?
It depends on our preference. See, if we want fast charging, definitely we need to go with the public charging stations. That's what I
Sir.
said. Normally, city drive, we return to home in the evening. Evening, we will be normally people plug in the vehicle. Maybe
Yes.
it takes 6 to 8 hours, and morning it will be ready. So
Yes.
across the globe, people prefer domestic charging. Only during the emergency situations or when you want to travel a long distance, then you need to go for public charging.
Okay. Thank you, sir.
Thank you.
Okay, sir. Thank you very much for your enlightening presentation, detailed about EV, and for your time also. So
Thank you, sir. Thank you.
So participants, sir's email ID is already there in NIT website, NIT Tiruchirappalli website. If you have any concerns or any clarification, you can send mail to sir. Okay.
Yes.
Thank you. So,
Yes. Yes. Sir,
thank you, sir. Thank you.
I take this opportunity to acknowledge my scholars and students, those who have contributed through the technical work as well as the articles. And I thank the organizer, Professor Sahu, for providing me an opportunity to interact with you all. Thank you.
Thank you. Thank you.
I log out.